Let's look at number 1 from your review packet. I want to kind of emphasize a couple things. First part, you are asked to just find the 95% confidence interval. That means you have to state, plan, do, and conclude. So the first thing we're going to do is state what we're going to do. We want to estimate the true proportion of students who registered to vote with 95% confidence. When I write that out, I emphasize a couple things. True proportion, that means I'm working with categorical data. That's important. That means I'm going to be using a Z interval. N is 50, P hat is 0.7. I'm pulling out what I do know from the problem. Next thing we do, make our plan. Got to make some checks and assumptions. First of all, independence. Well, I check. Our sample size is less than 10% of all of her students. We were told it was a random sample. And then we need to check, well, is it large enough? We have independence. That's our first check. Large counts tells us if we can use our normal calculations, if we can assume normality. Well, we can assume normality if n times p is greater than or equal to 10 and n times 1 minus p is greater than or equal to 10, which you can see it is. So we have at least 10 students registered to vote and not registered to vote. So now that we have met those conditions, we can calculate a 1 proportion Z interval for the students registered to vote. Context, guys. Always put these things into context. So here's my confidence interval. P hat plus or minus Z star times the standard deviation of our statistic. This is not on your formula sheet. Your formula sheet says confidence interval equals statistic plus or minus critical value times the standard deviation of your statistic. You have to know what to do. We're working with p hats. We wrote that up here. So I have to use the proportion standard deviation. This formula is essentially on your formula sheet, except it says p's instead of p hat. Well, we don't have p, so we have to use p hat. And you can see my calculations below. My critical value is 1.96. I found that with my calculator. You can also use your table. So we get this interval, 0.573 to 0.827. Now I'm going to jump down here. My conclusion is actually written in part B. It doesn't answer part B, but it was just written down there. I am 95% confident that the true proportion of students registered to vote is between 57.3% and 82.7%. All of this answers part A. Now let's look at part B. Explain what 95% confidence means in this. That's what I have written right down here. 95% confidence means that in several random samples of 50 students, in several random samples, you need to say that, 95% of the intervals produced will contain the true proportion of registered students. Again, I put it into context. On part C, you're asked to assess this 73%. Gallup says that the true proportion is 0.73. Well, does that seem reasonable based on our sample? Yes, because 0.73 falls within our interval. 0.73 is between 0.573 and 0.827. So that seems reasonable. And then the last thing we're asked to do is calculate sample size. If the professor only knew the information from September 2004 Gallup poll, so the only thing we know is that p hat is 0.73. That's it, guys. Notice we're using the 0.73. Don't go back to the original problem in part A. P hat is 0.73. I wanted to estimate the percentage of our students who registered to vote within 4% margin of error. With 95% confidence, how many students should she sample? All right, well, margin of error is the critical value times the standard deviation of your statistic. My value for 95% is still 1.96 times the square root of 0.73 times 0.27 all over n. Got to use some algebra here, guys. And we get 473.237. You always want to round up to 474. If you don't, your standard deviation is going to be too big, okay? You need to round up. So you lower your standard deviation so your margin of error is still within 4%, within 4%.